In this section, I will quickly go over the overall file setup and where each asset type is located. All of the assets are packed in these 4 folders, and each of the folders are named respectively with the asset type they contain. Let's jump into them. Materials folder contains, as the name suggests, the materials. Master Materials folder contains the 7 master materials used in the pack. Material Instances folder contains each of the material instances derived by the master materials. And these 2 are the reference texture maps used by the master materials. I will go in detail about the materials in the later sections in this tutorial video. Moving on. Mesh folder contains all of the static meshes available in the pack. Texture maps contain the texture maps used by the materials. Finally, in the utility folder, you can find blueprints, decals, particles, and landscape layer info for the landscape blend material. Blueprints are here, decals are here, particles are here, and the landscape info files are here. You can also find the example scenes here. Let's move into materials and go into detail about them. Materials. All of the materials are located in the materials folder here. There are a total of 6 master materials along with a landscape material located here in the master materials folder. Don't mind these texture maps as these are here for demonstration purposes only. Each master material is designed for a different workflow, which are then used in different assets via material instances. Each material has almost the same tweakable parameters, as well as similar shader graphs with little variations depending on the workflow they each represent. Let's dive deeper with them. The master material here is the master for tiling textures. Every ground material, like these ones, as well as wall materials, like these ones, are instances of this master material. Let's see it in action. Here is the material instance derived from this master material. Well, there are lots of tweakable parameters here, and let me go through each and every one of them. Let's start with the simplest ones. Here you can control the overall tints. You can go a bit extravagant if you want to. Here you can control the texture tile and sizes. For this one, let me just get to here. I think this will be a bit better. This master material is set to have workspace projection, and the texture size is controlled via a 3-vector parameter here. Each parameter controls a different axis of the projection, like here, the red channel, the green channel, and the blue channel. For instance, like this. Here you can control the overall roughness value. Here you can control the overall ambient occlusion value. Moving on. These texture parameter values section gives you the option to use your own texture maps if you want to. Let's say you don't like this ground texture and you want to use your own textures, then you can just drag and drop your own textures here and use them however you like this. Ambient occlusion, base color, normal map, roughness, and here is your new material. Metallic controls give you the option to tweak metallic values or use a custom metallic map of your own. By default, the metallic value of each material is set to 0. If you turn the controls on, however, it is by default set to 1. You can tweak the metallic intensity here, or you can use your own metallic texture map by enabling this 1K metallic parameter. Same as these ones, you can just drag and drop your own custom metallic map and use it if you want to. Because this is not a metallic surface, I'm just turning this off, which means I'm setting my metallic value to 0. Emissive controls are exactly the same as metallic controls with the addition of emissive tint parameter. If you're using an emissive map, you can just enable this here and drag and drop your emissive map here, just like the other ones. And you can tweak your emissive tint here. Since I don't have an emissive material, I'm just turning it off. For displacement, these displacement controls give you the option to use tessellation with a height map. Here, once it is enabled, it will require you to input a height map here. Since this material already has a height map, it doesn't require me to do so. Once you plug a height map, you can control your tessellation strength here. Or you can tweak your tessellation amount here. Finally, every material has the option to whether using 1K or 2K texture maps. This 2K on-off option lets you to switch to 2K texture maps. As soon as you enable the 2K on-off option, it gives you additional texture parameter options here. These options let you use your own 2K texture maps if you want to do so. This is it with the material instance parameters. Let's see what's in the master material itself. Here is the shader graph. Let's start with the simplest one. Here are the texture maps. The texture maps on top are for 1K maps, on bottom are for 2K maps. Texture resolution switches are happening with this static switch node, controlled by this static boolean parameter. When this parameter is off, which is its default state, the switch uses 1K maps. When this boolean switch is on, which is this one here, when it is on, the switch uses 2K maps. After here, the information from the switches come here, where the workspace projection is happening. The information is then fed into this world-aligned texture node. It is happening for each and every single one of them. And the texture size part here comes from this 3-vector parameter, which is this one. This parameter defines the tiling size for each texture map, and it is happening here in the texture size part of these world-aligned texture nodes. After here, the information is then fed into the shader. On top of here, in the color path section, you can tweak the color tint, which is this one. Here is the metallic controls. The metallic controls are controlled by this static boolean parameter here. When this is off, a constant value of 0 is fed into the material. Once this is enabled, the information from metallic maps comes here and is multiplied by a scalar parameter, which is our metallic intensity, then feed it into our material here. Here are the roughness controls. The roughness values from roughness maps are multiplied by a scalar parameter, which is our roughness intensity, and then feed it into our master material. Same goes for ambient occlusion controls as well. The emissive controls are exactly the same as metallic controls, which are controlled by this static boolean parameter and the static switch. with the difference of an emissive tint parameter here. And finally, the displacement controls are located here. The data from the height map comes here and then multiply with the scalar parameter. What this does is it defines how much of the data from the height map is in use, which means how strong the tessellation will be, our tessellation strength parameter. The information here then is multiplied by a vertex normal word space node. This node basically tells the shader where the vertices of a model or a mesh is located in the word space. This is the default state of our mesh without tessellation. The locations of each vertices are coming from this node. We then multiply the default position of the vertices with the information we get from the height map, and then we define new vertex positions, which is the tessellation itself. This is the default vertex positions, and this is the vertex positions after we multiply it with the information from the height map. The tessellation itself is happening here. After we achieve tessellation, we then multiply it with an object radius node. This gives the shader the information of a radius of a selected object. We don't need to do this actually, but if we don't do this, we need to take into consideration of the scale of different objects and input different parameters for each object, because scale of this object may not be and isn't actually similar to this one. So the tessellation here, the tessellation strength value for 0.02 may not yield the same results with this, as the scale of these two objects are vastly different. So by using object radius node, the engine basically tells the shader the radius of each object and helps us to kind of make this tessellation strength value a bit more uniform. Meaning, if we use this, then a value of 0.02 may yield similar results with both of these models. So once we get everything we need, then we feed it to this static switch here. This static Boolean parameter controls everything here, and if it's set to false, which is its default state, we feed a constant value of 0, which is nothing. We basically feed nothing, but once we turn it on, everything that I've went through is fed into the material here in the work displacement section. The second section, tessellation multiplier, is here. It's fairly simple. We use a scalar parameter to define how much of the vertices will be used to tessellate this object. And this is here. And both of these parts are controlled with the same static Boolean parameter. And that's all for the master material. Moving on, let's check the master_packed material. This master packed is the master material for channel packed textures. This master packed material has mostly the same parameters as this master material here, and has a similar shader graph with little differences. Let's dive into it. Here you can see all the tweakable parameters of this master packed material. As you can see, a lot of the parameters are same as this master material. The main difference is these texture parameter options. It only has 3 texture parameter options, one for base color, one for normal, and one for the channel packed texture. Apart from these, the UV controls are different too. Once you enable it, you have a U tiling option, a separate V tiling option, and a UV tiling combined option. For metallic controls, you don't need to import a separate metallic map, as we provide that metallic data with our packed map. Remember, the metallic data is available within the blue channel of our packed map, and as soon as we plug this into our shader, we provide our metallic information as well. Emissive and displacement controls are exactly the same. The 2K on and off switch has 3 texture parameters as well. You need to input a base color, normal, and packed map if you want to use it. Let's see the master material itself. As you can see, the shader graph is almost the same as the other one. The main difference being this master packed material doesn't have word space projection. Instead, it has a more conventional UV control options here. Here are U and V tiling options, this and this one. The UV tiling combined option. It also gives you the option to rotate your UVs if you want to, and it is controlled with this static Boolean parameter, which is this one. When this is off, which is its default state, it provides this texture coordinate node. When it's true, you can access all of these from here. Apart from these, all of the shader graph is exactly the same as our master material. Moving on, master standard material is built exactly the same way as master packed material, but for standard metallic roughness workflow. The tweakable parameters and shader graph of 2 are the same with only one difference. You don't need a channel packed texture for this master material. Instead, you use standard conventional texture maps. And this is the shader graph. As you can see, it's the same as the master packed material. Instead, this uses separate roughness, ambient occlusion, and metallic maps. Moving on, master fence material is the master material for switchable fence textures. It is similar to other master materials, but has the option to switch between 2 different textures. Let's take a closer look. Here in the material instance, you can see a lot of parameters are the same as the other master materials. The main difference being there are no texture parameter options here. Instead, the material gives you the option to switch between 2 different textures here. For both of the textures, both 1K and 2K maps are available. Apart from these, everything else is exactly the same as the other master materials. This is the shader graph. The main difference is there are a lot more texture maps here because there are 2 different texture sets with 2 different resolution options. There are 4 sets for each texture map type. 4 base color, 4 metallic, 4 roughness, 4 normal maps, so on and so forth. On a micro level, top 2 are 1K maps, the bottom 2 are 2K maps. Among those, this one is texture variation 1, this one is texture variation 2. So The texture's resolution switch is again controlled by this static Boolean parameter, along with this second static Boolean parameter, which is changing the textures. This one. This texture switch is the second static Boolean parameter. This master wall material is exactly the same thing as this master fence material, but with different textures, and there is nothing more to it. Moving on to this text material, it is fairly simple. This material is used for these text blueprints. Finally, this landscape material contains 6 different textures that you can use to paint your landscapes. And that's it for materials. Meshes. Meshes are located here in the mesh folder. Each mesh is ready to use with 1K light mesh resolution and applied textures. Texture maps. Texture maps are located here in the texture map folder. Texture maps are categorized by their resolution. 1K maps are here in the 1K folder, and their 2K counterparts are located here in the 2K folder. Apart from these, landscape layer blend material uses different set of texture maps, which are all 4K resolution maps, and they are located here. If you want to lower your landscape resolution, 1K and 2K counterparts of these landscape textures are available as well in their respective folders. 1K ones are here and 2K maps are here. And that's it for texture maps. Utility folder contains secondary assets, which are blueprints, decals, particles, and landscape layering for files. Let's look at blueprints. Blueprints are located in utility folder under blueprints. There are 3 blueprints available in this pack. The first one is BP spline tool. You can drag it to your scene, and once you do that, it will require you to assign a static mesh here. Let's do just that. Get to mesh folders, and let's use our wall mesh here. You can drag and drop it to here, and once you do that, it will require you to select the forward axis here. By default, it is set to X. By selecting additional spline points, pressing Alt and left mouse button, you can create additional spline points. You can just change the forward axis here and continue building whatever you want to build. Select the other spline point, press Alt and left click, create additional spline points. You can use different meshes as well. Let's get here, utilities, blueprints, spline. This time, let's use our fence mesh here. Set the forward axis to Y, and we can start building our fence. Selecting the other spline point, pressing Alt and left click, and drag. And we can create roads, fences, walls, whatever we want. The other 2 blueprints are BP text black and BP text white. These blueprints let you create text in your scene. Once you drag and drop it, you can select it, and here in the object name tab, you can type anything and it will be shown. You can scale it down or up and place it wherever you want. And that's it for blueprints. Decals. Decals are located in utility folder under decals. There are some preset decals that are ready to use, like these. you can use some grunge decals to add some variation to your scenes, like here or on your walls. More importantly, there's a master decal material here, and by creating an instance of it, you can turn your own textures to decals and use them as you want. Let's create an instance and drag this here. In the material instance, it will require you to assign a texture map here. There are some texture maps available in the textures folder, but you can use your own textures as well. Let's use this one. In the material instance, you can change the decal tint. You can add some stretches. You can adjust stretches styling. You can blend together two different texture maps, and those texture maps can be reached here. You can use different texture or grunge maps as well. Here are some additional grunge maps you can use. Let's just change them and change this one as well. You can create some custom decals here, and you can use your own textures for each of them. Additionally, there are some other scale parameters as well. Here you can adjust specular values, roughness or roughness variation. You can use metallic, the opacity, and finally the emissive intensity. Let's check the master material. This is the shader graph. First of all, the material is set to deferred decal, blend mode to translucent, and decal blend mode to debuffer translucent color normal roughness, because this way our decal will use the baked lighting data. Here is our decal texture, the main texture we need to use. Here are our additional texture maps, which are here. From our base texture, here we multiply it with a 3-vector parameter, which is our decal tint here. This data then comes here and multiplied by a scalar parameter, which is then feed into our emissive color channel, which makes this decal tint also our emissive tint. Here, for our extra maps, we have a simple tiling node structure here. And here, our two texture maps are being blurred together with a scalar parameter as alpha. And all of these actions are controlled with this static Boolean parameter. When it's false, it feeds a constant value of 1, which is our decal texture's own opacity mask. When it's set to true, the lerp action is happening and we feed that. Here in this scratches plus section, our opacity, original opacity from our original texture, is combined together with our opacity from scratches, and this makes our final opacity. We then multiply it one last time with a scalar parameter, which becomes our general opacity, and then we feed that into opacity. We use the same extra maps for our roughness variations as well. Here we lerp them together separately and multiply them with a scalar parameter, which will be our general roughness, and then feed that into our roughness. For our metallic and specular, we use a single scalar parameter. And that's it for decals. Particles. Particles are located in utility folder under particles. There are two particles that you can use. One of them is this falling leaf particle. It's a fairly simple particle system. This is the mesh that is being used by the particle system, and this is the material instance for it. It's a fairly fairly simple material. There's an overall color tint and two other color variations. You can tweak them to get a custom result of this particle system. The second particle system that you can use is this Fireflies particle system. It is again a fairly simple particle system that you can use to give your scene a bit more variation. And that's it for particles. This is the end of my tutorial. Thank you for watching and thank you for checking out this pack.